Okay, so let's start with, first of all, defining what parallel and perpendicular lines are. So I think we kind of know what parallel means, okay? Parallel lines are two lines that will never, ever, ever what? We want to be careful with when we say the word touch. Well, I guess technically, two lines that will, I guess they do intersect, that will, if they're, I'm talking to myself right now, that will never intersect. Okay? So two lines that will never, ever, ever intersect. All right? So that's a definition that you learned in geometry. I don't know, with Mr. Meeks last year or whatever, okay? So what we want to do is talk about how parallel lines kind of relate to what we've been talking right now in Unit 4 with slope and y-intercept and all that stuff. So if I were to ask you to take a look at y equals, we'll say 3x minus 1, and y equals 3x plus 2, okay? If I were to give you a piece of paper, ask you to graph this, what you would do is you would notice that both of the slopes are the same, right? And then they just are starting at different points on the y-axis. So here I would go down to negative 1, and from there I would go up 3 over 1. And I would connect my line, and I would have a nice straight line like that, right? So that's y equals 3x minus 1. So then we do y equals, let's make this 5 just to make it easier to see. Let's do y equals 3x plus 5. So I go up to plus 5. And now I still do what from plus 5? Go up 3 over 1, which is the same thing I did here. So think about it. By default, if I start at negative 1 and go up 3 over 1, and start at 5 and go up 3 and over 1, then these two lines are never, and depending on the way I hold my ruler here, they're never going to meet. They're never going to intersect. They are parallel to each other because they have the same slope. And lines that have the same slope are never ever going to intersect. Unless, what? When would two lines that have the same slope intersect? When it's the y equals 3x plus 4 or 5, y equals 3x plus 5. So I have two lines technically, and people debate about this. You're like, then you don't have two lines. You have one line. It's the same line, right? So if I ever give you that and ask you to graph it, you'd be like, that's kind of silly. So unless they fall right on top of each other like that, then they're the same line, then they're intersecting. So you could debate on whether or not they're intersecting if they're the same line. We're really only talking about one line. So basically you have the same slope but a different y-intercept, right? That's what parallel lines are, okay? So if I were to graph, right here, y equals 1/2 x and y equals 1/2 x plus 3. You know they're going to be parallel to each other because they're both 1/2. And I think, go ahead and cruising through this because I think we touched on this once already. Like we discovered it maybe when we were first learning about this. So this is the up 1 over 2. And then we'll move on from here pretty quickly. And then this is the plus 3, but still up 1 over 2, right? So just kind of different example, and they don't look like parallel to me because they might meet, but the way my ruler was held. So 1/2 x, 1/2 x, they're parallel. Easy, okay? Now, that's not all there is to it because we got to talk about how to incorporate the algebra part of it. So two lines that will never intersect, and I need you to add this. They have what? Have the same slopes. Just different y-intercepts, right? Bless you. Hi. What's up? You need your girl? Oh, don't you love it when Mom's here? You know how many times I had to sign papers of it? I'm in 6th grade. Come over. Sign this. I did let them all fix their problems, so they were like, I knew something was wrong. All right.
So you know when, except for Avery in this class, that I need to solve.
I know. Aw, you guys did the wrong problem. Oh, well. I'm glad we took care of it for 5th hour, so.
Awesome.
Thank you.
Yep.
All right. 2 lines that will never intersect, and they have the same slopes. Okay? Parallel lines do. So, let's talk about what your homework is going to look like today. Write the equation, because that's what we do in Unit 4, of a line parallel to y equals negative 4x plus 1. Okay. So, don't overthink this. Write the equation of a line parallel to y equals negative 4x plus 1. First of all, I don't really care about the plus 1. I'm really just focused on the fact that I need another line with the slope of negative 4 and just don't use the y-intercept of 1. Right? So everybody's answer could be different, yet still correct. As long as you put negative 4x and then whatever y-intercept you feel like, then you're good. Could you just leave it negative 4x? Sure. Means you chose the y-intercept as the origin, right? So could you choose plus 8, minus 2, plus 100, minus 70? Sure. As long as that is negative 4x, you're good. Got it? Okay? However, that's just too easy, right? That kind of problem they're not going to give you. They're not going to say, hey, write an equation of a line just parallel to it. They are going to say, write the equation of a line parallel to this line, but it also goes through, I should use this other line, that also goes through 2 comma, whoops, 2 comma negative 1. Okay? Now that's a little bit of a, a restriction. We have to make sure it goes through that point. So let's do this. I know that I know what you're thinking. You're thinking, okay, all I need is a piece of graph paper. I'm going to put the point 2 comma negative 1. I'm going to make it a slope of negative 4, which is down 4 over, did I make it go through that exact point? No. 1, 2, if it's down 4 over 1, then up here would be up 4 over 1, up 4 over 1. So really, aren't you just looking for a new y-intercept? Isn't that all you're doing? So I started at 2, negative 1, and look what my y-intercept ended up being, 7. So right now, I know that this is a line parallel to our original line with that goes through that point because I made it, and it has a slope of negative 4. So I know my new y-intercept is going to be 7, but you're not always going to have graph paper, right? So that's when algebra comes in. And here's the cool part about this. You've done this before. I know you did, okay? So basically I have y equals negative 4x plus some new y-intercept, right? So why did I put negative 4x? Because I need it to be parallel. So the slope that I choose here has to be the same slope that I put here. When it's parallel, you are just looking for a new y-intercept. And that's when you put plus b. And then what do I do at this point? Plug it in, right? So if y is negative 1, x is 2, and then you know what to do from there. Negative 1 is equal to negative 8 plus b plus 8, cancels it out, plus 8, and 7 is equal to b. And we knew it was going to be 7 because I showed you on the graph, right? So I'm not done yet because the question was not, what's the new y-intercept? The question was, give me an equation parallel to this negative 4x plus 8, but I need it to go through to negative 1. And it will go as long as the y-intercept is 7. So you got to wrap it all up, and this is your final answer, right? So y is equal to negative 4x plus 7 contains this point, and it's parallel to y equals negative 4x plus 8. So it's just a shifted down one, right? Kind of get that one? So let's take this next one and do another one. I need it to be parallel to y equals 1/2 x plus 7, and I need it to go through, meaning I need this point of 4, -2 on that line. So I can't just pick any old y-intercept. I can't just change that 7 to a 5 or a -2 because I won't be guaranteed that it goes through that point then. The only way to guarantee it's going to go through that point is if you incorporate that point into your work, right? So how should I set this up? I should set it up by saying y equals, well, I want it parallel, so I better keep the slope a half. If I don't, it's not going to be parallel. Then your plus b. Good? Then I go to work and I put the x in for the x. I still had a lot of people, this is not the order that these points go in the equation, right? That's the y, so you have to put the -2 here. I have people putting them in order. Don't do that, because you'll get a wrong answer. Y is -2, x is 4, so I'm looking for a new y-intercept. That's all I'm doing. -2, half of 4 is 2. Subtract 2 from both sides. -4 is your new y-intercept. So my new final answer is, okay, it's going to have to keep that slope because I want it still to be parallel to that original equation that they gave me. Except now instead of going through +7, it's going to go through -4. And I guarantee with the y-intercept and -4, it's going to hit that point. Okay? If your y-intercept is anything else but -4, it's not going to go through 0.4, -2. Do you understand? Okay, so I used that point to help me find the y-intercept, okay? And that's all there is to that one. So then you're going to see some things here. Line A, line B, line C. I'm going to give you 3 lines, and I'm going to ask you, I'm going to say y equals 3x minus 8. Y equals 1/5 x minus 2, and -3x plus y equals 5. Okay? And I'm going to say, which of these lines are parallel to each other? And here's the thing that you have to do. The first 2 are in slope-intercept form. I don't care about the y-intercepts. Basically, I can ignore all of these things right here, right now, because I just need to know what the slope is, right? And 2 of them are in slope-intercept form, and it's pretty obvious that those aren't parallel, because 3 is not the same as 1/5, right? So I know those aren't. But what you can't do is just look at the number in front of x and say, oh, the slope is -3. None of them are parallel. That's not the slope, because y is not by itself, right? So you know what you have to do. You have to get y by itself before you can compare them. And y is actually equal to 3x plus 5. And now is it parallel? Yes. So how would you write this answer? You would actually just write, if the question is going to say which lines are parallel to each other, you would say A and C. That's it. That's all you would write is A and C. Lines A and C are parallel to each other. And that's it for parallel. Got it? Okay. So let's move on to perpendicular. And here's the cool thing. The process is the same. It's the exact same, except we have to figure out one other little hitch here. So before I actually show you do the definition of parallel, I'm just going to, or perpendicular. I'm going to show you some perpendicular lines. You're going to study their slopes and see how they are related to each other. So let's take y equals 2x minus 4, and y equals -1/2 x plus 3. Okay. So if you think you know it right on the first shot, just wait a second. We'll do this. So I got -4 up to over 1. So here is my equation of the line. Y equals 2x minus 4. Okay? Now I'm going to do y equals -1/2 x plus 3. So from here I'm going to go down 1 over 2, down 1 over 2, and these lines look like they are what? So they're obviously intersecting, right? So we know they're not parallel. We knew they weren't parallel from the get-go because their slopes are not the same. There is something going on with their slopes, though. So I'm just going to pretend like I didn't hear that. So, unless it was, okay, Maddie usually gets. So these lines are what? If it was Maddie's, I was going to grab it. Okay, because she's on strike number 3. These lines are what compared to each other? Anybody know? What's the title of our lesson? Perpendicular. So I don't know. I know you are pretty comfortable with parallel. I don't know if you remember this from Mr. Meeks' class. I don't know if Mr. Meeks did this. But perpendicular lines are not only lines that intersect, because those are intersecting lines, right? They're not perpendicular. What makes it lines perpendicular? When they what, JC? Yes. When there are 4 90-degree angles formed. It is a the lines are perpendicular. The easiest way to teach this would be like to take a little Post-it note and see if you can fit it. And obviously mine is, human error here. But if it fits there perfectly, all 4 ways, then it's perpendicular. Mine's obviously a little off because my ruler. So if I use a computer to do it. So this is 90, 90, 90, 90. And by the way, that's where 360 comes from, a circle, right? So they're perpendicular and their slopes are 2 and negative 1/2. What's the connection there? You might need one more example. After the second example, that's when people... So right now, we're trying to do some detective work and figure out what is the connection between the slopes that make them perpendicular. I know they're parallel when they're the same. So y equals 2/3 x, and y equals negative 3/2 x plus 5. Remember? I don't care anything about the y-intercepts right now. I'm just analyzing those slopes. What is the relationship between 2/3 and negative 3/2? Nobody? Yeah. Okay, they are reciprocals, and that's one piece of it. There is also another piece of it. Audrey. Opposites. Okay? So, 2/3, negative 3/2. Negative 1/2, positive 2. So this brings on a need for a little conversation of opposites versus reciprocal. And I think that a lot of kids think they mean the same thing, and they don't. So the actual definition of 2 numbers that are opposites of each other are this. According to 0 on a number line, opposites are numbers that are the same distance away from 0. So negative 2 and positive 2 are both 2 spaces away from 0. Negative 100, positive 100 are both 100 spaces away from 0, right? That's what makes them opposites. So opposites are when the positive becomes a negative, or negative becomes a positive, right? That's what opposite is. When kids see a fraction flipped upside down, they think it's the opposite, but it's really not, okay? Because 2/3 and 3/2 are not the same distance from 0 on a number line, right? Okay? So I know you heard Mr. Meeks refer to it last year as multiplicative inverse, right? He made you say that. So opposite, reciprocal is what you'll hear most instead of... So reciprocal is when you take like A over B and make it B over A. It's also referred to as the multiplicative inverse. Okay? So just know that those terms are interchangeable. So, if I have a negative 4/5, what is the opposite reciprocal of negative 4/5? Positive 5/4, right? Positive 5/4. What is the opposite reciprocal of 7? Negative 1/7, right? Okay, know that? So, now we just discovered something out with perpendicular lines. If you're ever given 2 lines and the slopes are opposite reciprocals of each other, you can guarantee that they will be perpendicular to each other when graphed. Okay? So now, knowing that, as opposed to them being the same for parallel, we're going to go through everything we just went through with parallel, except now with perpendicular. So, for example, if I were to say to you, Let's just do a little, we'll do that summary in a second. Y equals 2/3 x minus 4. Remember the first time I did it, I said, just pick whatever you want. Just make sure that it's perpendicular to 2/3 x minus 4. Wherever you want it to go through, you decide. So, if you have no restrictions and the freedom to pick, then all you have to do is what? Write a line perpendicular to this line. No restrictions. I don't need it. So all you're going to do is say y equals what? Negative 3 over 2x. You can leave that. You could put plus 6. Could you put minus 4? Yeah, because it could have the same y-intercept, right? It could just be perpendicular. It's just flipped kind of 90 degrees like that. So you could keep the y-intercept, right? So, but they're never going to say that because they're always going to say, okay, but I need it to go through this point. So, write the equation of a line. This is what your homework is going to look like. When you get your packet, it's going to say, make it parallel, or make it this line, this point, perpendicular. Or this line, this point, parallel. So you have to know when to use the same slope and when to use the opposite reciprocal slope. So this time I want it perpendicular to, let's just say that y equals 2/3 x minus 4, except this time I need it to go through the point 6, negative 1. So this time you needed the new slope and a new y-intercept, right? So let's start to set this up. When you go to set this problem up, you start with y equals, and if you want it parallel, you would put 2/3. But I don't want it parallel. I want it perpendicular. So take 2/3 and make it what? Negative 3 over 2 plus b. Plus b. Every time you go, I don't know what to do next, I don't know what to do next. What do? Plus b is probably the step you're forgetting. Once you have it set up, then you know to put your x in for your x and your y in for your y. So y is negative 1. Get that order right. Negative 3 over 2 times 6 over 1. And I'm going to put that 6 over 1 just because it makes it a little easier for me to kind of see that I have to cross cancel. And this becomes 3. And this is negative 1 equals negative 9 plus b plus 9 plus 9. My new y-intercept is 8. Now be careful because I'm not done yet. This is a 2-point answer. You got 8. Now you got to wrap it all together. You got to tie it up and make sure that it's perfect. What line is going to be perpendicular to this line with this slope and this y-intercept? Don't do all that work and go back up here and write y equals 2/3 x. Because that would be parallel. You need it to be y equals negative 3/2 x plus 8. Correct? So this is really just a lot of algebra, right? It's just kind of knowing your equations. Solving equations is so important. So let's try this one then. I'll give you a minute to try this. I want it perpendicular to y equals negative 1/2 x. Perpendicular to y equals 4x plus 3. And I need it to contain the point negative 1, 4. So try that. Perpendicular. So the slope you must use is not 4. It's what? Oh, did I give you a yucky fraction to work with? Okay, that's okay. I meant to, but that's okay because it's this. Negative 1/4 x plus b. Y is 4. Negative 1/4 times negative 1. You guys can do this. Plus b. 4 is equal to positive 1/4 plus b. And then when I subtract 1/4, if you have $4 and you get rid of a quarter, you have what? Either 3 3/4 or 3.75 equals b, and that's okay. Sometimes it's not neat. Sometimes the y-intercept will be a mixed number. So the whole important part here is this. We're not done yet. We're not out of the woods. What is my final answer? What am I putting here? 4x or negative 1/4? Negative 1/4 x plus 3.75. Okay, last one here. Write it parallel. Careful, I just changed gears on you. To y equals x minus 6. Okay, you don't need to do the actual full problem yet, but what slope would you use? 1, right? So if the slope is 1, then you would say y equals, and if the point was, say, 5, 2, you would say y equals 1x plus b, and then you'd put this point in there, right? So x would actually just be 2. You won't have to multiply by anything, right? It gets tricky, however, if that was negative x, right? So that would mean if y is negative x, what is actually this? What is going to go right here? Negative 5, right? And what if this was negative 5 already? That would be positive, okay? Here's what's crazy. Write it perpendicular to y equals negative x minus 4. What is the slope that's perpendicular to a negative 1? Right, you're like, what do you mean? Because what is the reciprocal of 1? 1. Because 1 over 1 is the same as 1 over 1. So what slope would you use if you were given a negative 1 and it needs to be perpendicular? Positive 1, right? You just have to use positive 1. You can do the opposite, but you can't really do the reciprocal of 1 because it's the same as 1, right? Okay. So perpendicular would just be negative, or a positive 1. All right, last one here. If I gave you line A, line B, and line C, y equals 5x minus 3, x plus 5y equals 2, and negative 10y minus 2x equals 0. And I'm asking you to tell me which ones are parallel and which ones are perpendicular. And they're all a big mess right now, right? So you can't really do anything except A is kind of good. Right now, I know that the slope of line A is 5. I don't know the slope of B or C, but you know how to find it, right? So go ahead and take a minute and see if you can find the slopes for B and C. You know what to do. I shouldn't have to tell you that now. And this one's always a little tricky, right? Because you kind of look at that and you're thinking, what is the slope? What is the slope? It's awfully nice when 5 goes evenly. Like if that was 10, boom, slope's negative 2. That is a 1, which means your slope is actually what? Negative 1/5. And I don't really care what the y-intercept is, right? I don't, because I mean, you can go ahead and write if you want, but I don't really care. So that's B. C then would be You're going to add 2x to both sides, so that's going to give you negative 10y equals positive 2x. Don't even have to put plus 0. Divide both sides by negative 10. And y is equal to what? Negative 1/5. So here's what I would do if I were you. I would go back up to the top and get them all straight. So I would say A is 5, B is 1/5, negative 1/5, and C is negative 1/5. Now I have to go over here and kind of tell which ones are what. So right off the bat, what's the easiest one? And which are they? B and C, right? So B and C is all you have to put under parallel. And for perpendicular, there's a couple ways to write it. You can choose however you want. So give me 2 lines that are perpendicular to each other. A and B. And another 2. A and C. Could you just put A is perpendicular to B and C? Does that make sense? So A to B, A to C, or A to B and C. However you want to write it, I'll accept either. Okay. How do we feel about parallel and perpendicular lines?